Greetings, my name is Seth and I'm a support engineer with NXLog. In this video, I am exploring passive network monitoring and logging using NXLog Enterprise Edition and the included IMPCAP module. I will be using the passive network monitoring abilities of NXLog Enterprise Edition to capture and log questionable network-related events such as Rogue DHCP Server replies, unexpected ARP and ICMP sweeps, and DNS tunneling. With passive network monitoring, administrators have the opportunity to capture network traffic from devices that are not configured or cannot be configured to forward network activity logs, as well as devices on the network they may not be aware of. In this tutorial, I'll demonstrate how NXLog Enterprise Edition using the IMPCAP module can be used to identify large or repeated ARP and IMCP sweeps on the network. These are generally done to identify all devices on a network and may signal malicious intent. I am going to configure NXLog Enterprise Edition using the IMPCAP module to send events to my mock SIM when there is unusual ARP or ICMP activity on the network. In this configuration, I have again defined the interface at the top of the configuration. I have also defined several IP addresses that will be whitelisted and allowed to produce unusual or high network-related ARP and ICMP-related traffic. Lastly, I have defined two values which will be the ARP request and ICMP request maximum allowed threshold. In my primary input section, I will be filtering for ARP or ICMP traffic and retaining ICMP, IP, Ethernet, and ARP data from the received frames. Notice in this configuration I have a more complex exec section with several conditionals that set and track multiple variables based on the traffic captured by the IMPCAP module. First, I am checking if the captured traffic is from one of the whitelisted IP addresses. If so, the captured traffic event is dropped. Then I check if the event is an ARP or ICMP request. If it is an ICMP request, I check if there is a variable currently set named ping requests, which is used to track the number of ICMP requests received. If not, a variable of that name is created with a lifetime of 1 second and then given the value of 1. If the variable is set, the value is incremented by 1, and then checked if the threshold value defined above, in this case 10, has been reached. If the threshold has been reached, a new event field is created named Network Event, and a message concerning the high ICMP traffic is added and will be sent to the mock SIM. If the threshold has not been met, the event is dropped. This means that if NXLog captures 10 or more ICMP-related requests from a non-whitelisted IP address in a single second, an event is then sent to the mock SIM. If the capture is an ARP broadcast event, a similar process happens. The ARP request variable is checked for and created if not found with a lifetime of 1 second and initialized to 1. If it does exist, the variable is incremented and then checked to see if it has reached the threshold value, in this case 30, which was defined above. If it has reached the defined threshold, a field is created named Network Event, and a message concerning the high ARP traffic is added and sent to the mock SIM. I will now start NXLog Enterprise Edition using this configuration. Using a custom Python script, I will perform an ARP sweep on my machine subnet. As I start the sweep, remember that until the threshold is met, the events will be dropped. Looking at the data coming into the mock SIM, I see the threshold has been met, and I can now see the details about the broadcasts. I will now also perform a ping sweep of the network. As with the ARP sweep, once the ICMP request threshold is met, events are set to the mock SIM with the associated warning message. As an administrator, I am now aware of the sweeps and can investigate further if needed. Note that it may be beneficial to set up whitelists from MAC and IP addresses that are known to have high network activity, such as load balancers, default gateways, or other network monitoring appliances. It is also important to note that the threshold values chosen here are arbitrary, and you will need to look at averages for each network to determine ideal baseline values. For more information and configuration details for the IMPCAP module, I encourage you to review the IMPCAP module section in the NXLog Enterprise Edition user guide. This concludes the second tutorial in the Passive Network Monitoring and Logging with NXLog Enterprise Edition series. In the next tutorial, I will look at how NXLog Enterprise Edition can be used to monitor possible DNS tunneling activity on a network. If you have any questions or would like to request a trial of NXLog Enterprise Edition, you can do so online by visiting nxlog.co/request trial or by contacting our presales team at presales@nxlog.org. Thank you so much for joining me for this tutorial. I hope it was informational and enlightening, and I hope you have a great day.